So we are learning the embedded programming. So today now our program is a write assembly level program to toggle a port. So what we have to do is we will be using hardware and we will be toggling the port. So I'll tell you a little bit about. I already discussed you with you in an earlier section. Like say we are using the. So earlier, like in this microcontroller, we are having the 4 port. So we are having a port 0, port 1, port 2, and port 3. Like that, we are having the 4 ports are there. So when we say like toggle the port, in the sense what we are trying to say is we want to make it high, low, like that. We want to toggle the port, and this difference will be very low. It will be like approximately 2 microsecond or so. It will be very low delay, around 2 or 4 microsecond, like that much. Very small delay we will get. So for that we have to use the logic analyzer to So we have to use the logic analyzer to understand see this way, so that we will be showing you how to do and what to do. So let's start writing program. Here we are making the new project, so we can go new project and like we can give the name. So we can give like toggle 1, because we want to toggle our port, and here we are selecting the microcontroller. So 89S52, it is 8051 microcontroller.
Sir, I have one doubt.
Yeah, tell me.
Why we are using 8051 microcontroller? Like we can use advanced microcontrollers also here.
Yeah, you can use advanced microcontroller also, but like 8051 is one of the best and simple microcontroller for the learning. And here in this lecture series we are not learning 8051. 8051 we are just using as a device to move from one area to other area. To learn embedded system we are using 8051. So 8051 is not a bad controller, it's very good controller, and now also in industry 8051 is widely used across the industry. And this is the simple microcontroller, and the more better part in 8051 is like you have to do everything and you can see one by one what is happening. That is the advantage of 8051. Once you learn how embedded work, any microcontroller you can use that knowledge. Any microcontroller, ARM and all advanced microcontroller also work with the same concept. So now we'll go here, right click, and we can go to the add new item, and then we will create a ASM file. So we are writing program in assembly. So again, like I'll say the toggle 1.
Sir,
and this
one more doubt I have.
Yeah, tell me.
Like you selected assembly language there.
Yeah,
so
we are writing program in assembly language.
I think assembly language is very old language. We can use C also. Why we are doing in assembly?
Yeah. It's not like we can assembly is old language. It's not like that. How you see, like how it happen, I will show you. Consider like say this is my hardware. So this is my hardware means it is my microcontroller. So microcontroller, whatever program you will be writing, that it will work with the binary. So it will work with the 0 1 0 1 0 1 0 1 1 1 0 0 0 0 1 1 0 0 1 1 1 0 1. So this hardware is only understand 0 1 0 1 0 1 0 1 0 1. Only any microcontroller, any electronic hardware only can understand zeros and one. That's all, because it's a digital devices. This zeros and one is difficult to understand, so we convert them into hex. So that is called the opcode. So we are having the opcode, and then we are writing on top of that, we are having assembly level language. On top of that, assembly level language. On top of that, we are having C language. On top of that, we are having graphical language. Like you maybe seen the lab view. Had you seen the lab view? In the lab view, you can just having the boxes. So you just pick the box and put it. Automatically, this C code also you no need to write. So in this lab view, you will having just box. Consider if you want for loop, take one box and put it here. It will automatically for loop work for you. They will write for loop for you. If you want while loop, or if you want switch case, or if you want anything, you just pick it up. He will give you. So this is like a graphical language. So this is graphical language. This graphical language is converted into C, and then C is converted into assembly, then assembly is converted into this mnemonics, and then it will converted into this binary. Then it works. So you see, you tell me which one is old language here.
Seems no language is old language, but assembly language is very close to.
Yes,
the hardware.
assembly language is very close to hardware. If first time we are learning embedded system, what we are doing, we starting from like this, we are going up. So if you directly coming from top or something, like you will be missing many things, because you will get chance to learn all this thing, what is the actually happening behind the scene. Consider like if you directly start learning the car, how to drive car, you will not understand how to drive bicycle. It's something like that. So and in few sometime, of course, like you can say like you learn car, then why you need to learn bicycle? Yes, of course. But sometime in your life you may need it, this knowledge, and that time learning this knowledge will be very challenging, because you already crossing like 5 year, 6 year, 10 year experience in your life. So that's why.
So one more doubt I have here.
Yeah.
Like these are all languages for communicating with hardware. So is there any difference in execution time?
Yes, execution time comes different when we use this kind of language. When they convert into C code, they will use some extra code. When C convert in assembly, they cannot write the optimized C code as we are writing, because we directly writing it. So definitely when we write assembly program, that we are writing the more sophisticated code directly, and then subsequently it happens. So if some C compiler, if you want to do something, consider here only. Let's go to the program. We'll discuss this in a program also. Okay. So I'll answer this question like if we writing program in other language, how it impact the size of the code. So let's write program. So we want to toggle the port. So okay. So org0.
Sir, one more doubt.
Yeah.
We started with org0.
Yeah.
What is org0 actually?
org0 means like it's we are telling compiler or assembler to write my code in the 00 location. And I'll show you one example. Consider like if I say move port 0. Let me finish this program, then I will tell you about org. So hash 00 h, and then like so now if I compile this code, okay, one warning, missing a statement. So now this is currently org0. If I compile this code and if I debug, you see my code is starting from 0 location.
Yes.
But if I write org5, you see in 00 I don't have any code.
Okay. So
My entire code is moved to 5. So this we are telling to compiler from where we want to save our code. So we want to save our code from the beginning. Why? That I will tell you in a future lecture. So we have to start from 0. Why we have to start from 0? That I will tell you in future classes. So we are starting from 0. Then what I did, I made port 0 as 0, port 0 as high, and we are having 4 port 0, port 1, port 2, port 3. So we are using port 0, any port we can use, and then we are jumping from here L1. So this is my L1 level. That's all. Infinite loop we are having. We will making high low high low high low high low like that.
And what is that L1?
L1 is a level, means like we want to say jump where? So we are saying jump to L1 like that.
Okay. So instead of L1, can we use anything like P1?
Yeah, we can say like hi, or we can say hello.
Okay, it's kind of variable.
It's not a variable, it's a level we can say. We can't change this. Variable we can change, but we can't change this thing. We cannot write any values. It's not a variable, but we can jump from here to here like that.
Okay.
So now let's compile it. It's done. Now we are going to run this program in our hardware. So for that you have to go here, this place, option, and you have to go for output, and then you have to create hex file. This you have to do it.
So what is a hex file?
What is hex file is okay. Consider I will not click that. If I run this program, I'll tell you what is hex file. You see, this line is converted like this. So we are having a instruction that is 758000. See this program. So 758000. So 758000, then 7580FF, and then 80F8. So this is your hex file. So when I say hex file, this is your hex file. This file you need to download inside your microcontroller. So this is your microcontroller. This file you have to download inside the microcontroller. So now this is the code. I'll generate. Currently, actually, it is not generating hex file. So I'm telling him, hey, look, I want hex file. You copy this file for me. So he will make separate file. And here we can give the name of file. Okay, so we'll say okay. Now when we build, so it create hex file. So it will say to me creating hex file like that. So he created hex file like that.
Okay, so only after building a hex file will be created.
Yeah, after building only hex file will be created. This you no need to change again and again, but for every project at least one time you have to make it. Fine. So where we did, we went here, output, and we enable this checker. Then we build it. Fine. Now we have to download this program into our board. So we will download this program into our board. For that we are using the utility called we are using the Nubotron. So we are using utility. Now let me connect the hardware.
Sir, is this a specific software for uploading the code or?
Yeah, this Nubotron utility we are using to download the program. So what we have to do, we have to connect our hardware as we are showing in this video. You have to connect first hardware, and after that, once your hardware is ready, now what you have to do is you have to first select the output file. So you can see you have to select this ISP by COM port, and then you have to select your COM port. If you are facing some problem, like if your COM port is not detecting, then see our other video. That will be, you need to download the driver. So once your COM port is coming here, then you have to select the microcontroller. So you have to select this microcontroller W78E052D. That once you get the hardware, you will understand this, and then you load file. So we'll go that And see, just now we had created this file. So you select the file and you say open. So that whatever file we wrote, if you remember in the that place also we wrote same file. So this is the same hex file, it's loaded here. And now we are saying update chip. So it's very easy to update chip. Just press the reset button and your program is now done. Successfully it done. Now your program is already running in the microcontroller. Now we have to just check it whether it's coming properly or not. For that we have to use the software called Logic. Currently we are using port 0, so you can connect port 0. One is ground pin. You can connect to ground, and then you can connect to any other channel, and then you can connect your logic analyzer.
So do we need to connect to the port which we used in the program only, or any
Yeah. See, we are toggling port 0. We are toggling port 0. So port 0, any pin you can connect, because we are toggling all 8 pin.
Okay.
So any pin you can connect. So I connected I'm just running the logic software. You can see in hardware also. Now if you zoom it, you will understand. See, this is 2 microsecond, 4 microsecond, 2 microsecond, 4 microsecond. This is 2 microsecond, 4 microsecond. Okay, so this is how your port is toggling. Any question in this?
Sir, why it is one is 2 microsecond and one is 4 microsecond?
Yeah, see why we are getting 2 microsecond and 4 microsecond, because from 0 to high we are having only one instruction, but high to low we are having one is this instruction and one is the jump is also there. So jump also will come here, and then we are making it low. So from low to high we are having very short time, but from high to low we are having one extra instruction here. So this instruction also taking time. So he is taking time, then he is taking time, after that it becoming 0. But low to high we are directly becoming. So if you see, the low to high will be very less. But high to low will be taking time, because we have to do extra work. So hope you understand. I query your some of the question. If you have still query, you can send us, you can comment us, you can like, subscribe, you can comment, and this you can see in a hardware exactly as shown in a video. So you will be definitely understanding this. Okay. Thank you for watching.
Thank you.